Hey fam, it's your boy, Mr. Wishart, coming at you from, I don't know, I guess math class. Anyway, this is 5.2 where we're solving two-step equations, not just writing two-step equations. Gosh, I need a haircut. All right, so Elizabeth wrote the following clues. These guys right here. What is the relationship between the shapes? So we got blue circles, red triangles, and we got green squares. I'm going to get a green pen. I'll be right back. All right, sorry. Okay, we got to figure out the relationships between the shapes. Basically, how much each shape is worth according to the other shapes, right? So what we can do here is we can basically cancel things out because we got an equal sign right here, here, and here. So these are technically equations, right? Let's kind of split them up and use that information to help us, right? So I got a triangle here and a triangle here. I can basically cancel the triangle here and cancel the triangle here, okay? And that leaves us with four blue circles, and two green squares. Now, the idea here is that if I kind of split that up, let me do a color here. Right? How do I want to represent this? We can actually take this square and get rid of those two, right? Because if we have four here and two here, one is worth two. All right. So that means we've got to, let me do this the right color here. Circle plus circle is equal to square. So basically, two circles is one square, or one square is two circles. Okay. All right. Now, let's do the same thing here. We've got two circles on each side. I've got a circle here and a circle here and a circle here and a circle here. We can get rid of those. So now we've got it broken down. We got three triangles left. Right? And we can set it equal to one green square. Okay. So now we can kind of see that one green square is equal to two circles, and also one green square is also equal to three red triangles. And so when we look at this right here, we can kind of start substituting these things in, right? I know that I've got two blue circles here, and I know that that's equal to one green square, right? So I can say this green square and this green square, right, is equal to, well, I know that I have three red triangles, and I know that's one green square. And I have another set right there. So just by substituting in, I can figure this stuff out, right? So I can say that, let's just kind of summarize down here, right? I can say that one green square is equal to two blue circles, right? I can also say that one green square is equal to three red triangles. And because of that, I can say that two blue circles is equal to three red triangles. Okay. I could break it down even more. Like I could, let's see. Yeah. Anyway, I don't know. This is exactly what we do in algebra class or in math class. But instead of shapes, we use numbers, right? So it's the exact same thing we're doing. Okay. So Nala and her friends spent $21 on movie tickets and a box of popcorn. How could they figure out how much each movie ticket costs? I got the price of the popcorn as 6. I'm going to say T equals price of ticket. Okay. I know that there are 3 tickets. Okay. So I can say T, T, and T. Those are the 3 tickets. And I know that the price of the popcorn is $6. Okay. So let me zoom out just a touch here. Okay. I can put this together in an equation, right? This is t plus t plus t plus 6 equals 21, which I can simplify that even more to 3t plus 6 equals 21. Okay, because I got three t's, I can kind of put them together like that. Okay, now what we do to solve this equation is we do the inverse of what's happening, basically, to get this 6 over here. I want to match these numbers up. These are just regular numbers, so I can put them together. It's called combining like terms. And I'm going to do the opposite or the inverse of addition. La apuesta de adición es subtracción o menos, ¿sí? O resta. So those cancel out because that's 0, and I do the same thing on the other side. So I end up with 3t is equal to 15. And then I have multiplication happening here. Whenever you have a number next to a letter, that's multiplication. And the opposite of multiplication, or the inverse, is division. So la apuesta de multiplicación es división. So divide by 3 on both sides. 3 divided by 3 is 1. So I get t equals 15 divided by 3. 3 goes into 15 5 times. Okay. Now we refer back to when we defined our variables, t is equal to the price of each ticket. So that means that the price of a ticket is $5. Right? Okay. So we would summarize this by saying the price of the tickets is $5 each. Right? Or each ticket costs $5. Kind of either way works for that. Okay. Now we got a similar question here. Andrew rents bowling shoes for $4. He bowls 2 games. He spent a total of $22. How much was the cost of each game? B. Okay. So we'll say B equals the cost of a game. Okay. And we've already got this set up right here, right? I've got the B, and the shoe rental is, where is that? $4, I think, right? Rents bowling shoes for $4. We actually do a different color here. Okay. And he spent $22. So that's the total. That's kind of why this rectangle covers all 3 of those smaller rectangles. Okay. So when we set our equation up, it's going to be b plus 4 equals 22. There's 2 b's, so we can combine them to get to 2b. This should be equals, my bad. Now, we've got addition. We got to do the opposite. So we bring that 4 over to the other side. We get 2b equals 18. And we got multiplication here, and the opposite of multiplication is division. So we divide, and we get b equals 9. And so b is the cost of a game. So each game costs $9. You're good. Keep going. It's fine. Yeah, you're good. You're good. So that would be our answer there. Okay. Okay. This kid, John, has a $21.61 balance on a gift card that can be used to purchase online music. Each song download costs $1.29. John wants to maintain a $10 balance to purchase a new album that releases next month. So basically, he wants to save $10. How many songs can John purchase? Well, we've got this kind of set up right here. What variable did I use when I did my answer key for this? Oh, they do n for some reason. Oh, n, the number of songs. Perfect. So n is going to be the number of songs that he can purchase. Okay, so that's going to be right there. We know the cost of one song is $1.29. Okay, and we're taking that away from the balance, which is that $21.61, and we know he wants to save $10. So that's how we set it up. So let's kind of like compress that a bit. I got $21.61 minus $1.29n equals 10. Okay. Sorry about that, guys. Now, we got to get this 2161 and combine it with that 10. This is a positive 2161. When it doesn't have anything out front, it's positive. So we're going to subtract because that's the opposite of being positive. It would be negative. That cancels. So we're left with negative 129n. It is important that you keep this negative with that number. Otherwise, you're going to get the wrong answer. We subtract here. We get to negative 1161, right? You can use calculator. You say 10 minus 2161 gets us to negative 1161. Okay. And then we're going to take this negative 129 and divide by negative 129. Hold on, I'm going to close the door. I'm in the middle of shooting a video. 3 minutes? No, but I got about 3 minutes left. Yeah. Can you close the door? Okay, thanks. Oh, do you want me to come grab you?
What?
Do you want me to come grab you? Where are you?
I'll be in the office.
Okay, cool. I'll text you. Okay.
I don't have my phone.
All right. Okay. Those cancel out. And now we're going to divide right here. So we're going to end up with n equals whatever this is. Now we have two negatives. So whenever you divide negatives, you're going to end up with a positive, right? Which makes sense because you can't have a negative number of songs that you download, right? So we're going to take that negative 1161, and then we're going to divide by negative 129, negative 1.29. And we end up getting a value of 9. So n equals 9. Okay. If you're interested, this is the Desmos scientific calculator. Yeah, I don't know. It's a good calculator. It's free. Okay, so we refer back to our variable. N is the number of songs. We've got 9 of them, so we can say he can download 9 songs. Okay. All right. Now, this is asking us to kind of look at algebraic and arithmetic solutions. Algebraic is when we use variables. Arithmetic is when we just use regular operations like addition, subtraction, multiplication, division. So, number of trumpet players is 2 more than the entire band. How many students are in the band? And we've got this little blip of information right here that can be kind of hard to see. We know that 18 students play the trumpet in the band, right? So what variable did I use? I think I did B. Okay. So B equals the number of students in band. Okay, so that's our variable. So number of trumpet players is 2 more. Okay. So whenever you see is, that's an equals. 2 more than is plus 1/4 of the entire band, which is B. So we can say 1/4 B plus 2 is equal to the number of trumpet players, which is 18. Excuse me. Now we'll solve just like we've been solving, right? We take this 2, we got to bring it to the other side to combine it with that 18. It's adding, so we do the opposite, which is subtraction. We get to 1/4 B equals 16. Now this 1/4 B is the same thing as B divided by 4. Okay, that's the exact same thing. There's an invisible 1 out there if you do that like this. And now what we do, since we have division right here, I'm going to multiply on both sides. Those cancel out. B is equal to 4 times 16, which is 64. Okay. So there are 64. Let me actually write a full sentence. There are 64 students in the band. Okay. Now, if we look at this arithmetically, okay, we know that the number of trumpets players is 1/4 of that band, right? But it's that trumpet players minus 2. So 18 minus 2, number of trumpet players minus 2, times 4 gets us to the number of people in the band, right? So that's 4 times 16, which is 64. So similar. I mean, these are all solved the same way, right? We do opposite operations or inverse operations, right? Addition and subtraction are opposites, and then multiplication and division are opposites. And so that's kind of how we approach every one of these problems. Okay.